Hello, good morning everybody. So today I wanted to solve a question of altimetry. There are plenty of altimetry questions in the EASA database. So here it is, you have it on the screen. So we have an aircraft that is expected to clear a terrain by 2000 feet. The elevation of the mountain is 6254 feet and the local QNH at an airport of elevation 3,100 feet is 901 HPA with a EASA deviation of plus 24 degrees, so warmer than EASA. Calculate the flight level in order to clear the mountain range by the specified clearance. And the question mentions that 1 HPA is 30 feet, which is the official value that you have to take in the EASA ATPL exams all the time, unless something else is mentioned. Okay, so we have four options: flight level 85, flight level 70, flight level 75, flight level 95. So how do I solve that? The first thing I do all the time is to draw the situation so that I have a clear picture of the situation. Okay, so we have the mean sea level, okay, with a QNH of 901 HPA. We have a mountain that is climbing up to 6,254 feet. We have to comply with a clearance of 2,000 feet, and we have an airfield for which the QNH was calculated and the standard and the deviation from the standard atmosphere. And this airfield is at 3,100 feet. Okay, and the question mentions that we have a deviation of temperature by 24 degrees. So EASA deviation 24 degrees warmer than EASA. All right. So EASA plus 24 degrees. Okay, so first of all, the things that you have to take care of here is that in that type of question in which we talk about terrain clearance, obviously we have to take into account the true height or true altitude, okay, because whatever happens, we cannot fly below that level. Okay, so then the corrections of temperature and everything that we have to do, obviously, they have to be calculated on that column of air, okay, from the airfield on which the QNH and the temperature were determined, obviously. Okay, so what do we have here? Um, we have an elevation of the airfield 3,100 feet, and we have true altitude that we have to comply with of 8,254 feet. Okay, so it means that if we fly at this altitude, okay, we must comply with a true height of 8,254 minus 3,100 feet, which is a true height here, a true height, I insist on that, of 5,154 feet. Okay, and this is, we can note it, the true height on which we have to comply with. Okay, so then there is to apply, obviously, the temperature correction in order to find at which what would be the true height indicated. No, sorry, what would be the indicated height that we would have on the altimeter, okay, if we fly at this altitude exactly. Okay, so here it's very simple because the question says that we are at EASA plus 24. So we have, if we have an EASA plus 10, we know that we have a difference of plus 4% between the indicated height or altitude and true height or altitude. If we have plus 20, we have plus 8%. If we have plus 24, here we just calculate a proportionality. Okay, so 8 times 24 divided by 20, we have a correction of 9.6%. What does it mean here? It means that the true height or the true altitude will be 9.6% higher than the indicated height or indicated altitude. So here we have a correction factor here that corresponds to that value of 1.096. So then we have a formula that works absolutely all the time. That is the true either height or altitude. So in our case is the true height. That is equal to the indicated height times that correction factor of 1.096. Okay, so then it's very simple because we have the true height directly, 5154, that we divide by the correction factor of 1.096, and this gives us the indicated height. Okay, so here we have indicated height of 5154 divided by 1.096, that is 4,702 feet. Okay, so that value would be the indicated height that you would have in your altimeter if you fly exactly here at the top of the clearance. Okay, and if you had set the QFE on your altimeter. So then obviously we have to convert that into an indicated altitude. So here we just have to add the elevation, that is 3,100 feet. So that value plus 3,100 gives us an indicated altitude of 7,802 feet. So here we have just added the plus 3,100 of the elevation. Okay, and from this indicated altitude here, obviously, after that, the correction to apply is the flight level, so the pressure correction. So in this case, if the QNH is 901 HPA, obviously the 1013 is below. And how many HPA difference do we have between 1013 and 901? We have exactly 22 HPA, which correspond to, if we take 1 HPA 30 feet, 660 feet. So to fly exactly at that level here, we need to fly at a pressure altitude that is, so here I note it like that, pressure altitude, understand when you have set the altimeter to 1013, of 7802 plus 660, which is 8462 feet. Okay, is this a flight level? No, obviously. So what is the next flight level at which we are able to fly? The one that is just above flight level 85. Okay, flight level 85. What is the answer? Answer alpha. Here it is. Okay, so I hope that this has helped you. Enjoy, and please leave your comments if you have any comments, and just have fun with the ATPL. Ciao.